Hi, I am Sam, your teacher. Sam, my teacher. Sammy, teacher. Are you good at basketball free throws? How many free throw shots can you make out of like 5 tries? As for me, I could make 2 or 3 out of 5. But let's suppose my free throw percentage is 80%, which means if I do 100 free throws, I would make 80 of the shots and miss the other 20 shots. If I do 10, I would make 8. And if I do 5, I'd make 4 shots, which would be pretty good for a non-professional player. So, I'm gonna show you my imaginary self doing 5 free throws. Here goes the first try. Okay, that was a clean shot. Okay, I thought I was gonna miss it, but I made it. And my third throw. Okay, no! Ouch! I missed the third one. I guess I have to make the other 2 shots in order to make 80%. And here goes the shot number 4. Alright, a clean one again. Now, I'm supposed to make this last one. And here it goes. Okay, no. Yeah. Did you see that? I made the 5th one too. Now that I showed you my free throw percentage is actually 80%, here goes the question of this video. If I do 3 more free throws, what is the probability of making at least one of the 3 free throws? Before we jump right into the question, let me make a couple of things clear about probability. Probability is a number between 0 and 1. If we can never get a certain desired outcome, the probability will be 0. On the other hand, if the chance of getting the desired outcome is 100%, then the probability will be 1. And one thing you should know about a number between 0 and 1 is that when you multiply those numbers, for example, probability 1 and probability 2, the number gets smaller and smaller. For example, 0.5 times 0.5 will be 0.25. But when you add the probabilities, for example, probability 1 and probability 2, the number becomes greater than each one of these probabilities. As an example, 1/3 plus 1/3 equals 2/3. Let's say we have 2 probability questions. One of them asks us to find the probability of having the head of a coin and 6 dots on a piece of dice. And the other question asks us to find the probability of getting the head of a coin or 6 dots on a piece of dice. Which probability do you think is higher? In other words, which one is more likely to happen or more likely to get the desired outcome? Obviously, this is more difficult to get because you have to satisfy this condition and this condition at the same time, compared to this one, where we can just satisfy this condition or this condition. So let's try to find the probability. The chance of getting the head in a coin is 50% chance, or 1/2 in fraction. And the probability of getting the 6 dots on a piece of dice is 1/6. When you have to satisfy both of the conditions, you multiply the probabilities, and the result becomes 1/12, which is smaller than each of the probabilities. And in the OR condition, this probability and this probability is the same. But here these probabilities add up. And if I change this to common denominator 6 by multiplying 3 and multiply the same number here, 3/6 plus 1/6 will add up to 4/6. which reduces to be 2 over 3. And we can see that this probability is greater than each of the probabilities. You might already know this idea, but since this idea keeps appearing in probability questions, remind yourself that when you have AND condition, you multiply the probabilities. And when you have OR condition, you add the probabilities. And remind yourself also that when you multiply probabilities, it gets smaller. And when you add probabilities, it gets bigger. Now, we're back to the original question. If my free throw percentage is 80%, which means I have 80% chance to make the shot, and I do 3 free throws in a row, what is the probability of succeeding at least one of the 3? Now, there are many possibilities of making at least one of the 3. I'm going to show you a long way to solve this problem first. I'm doing 3 free throws. 1, 2, and 3. When we say make at least one of the 3, I could just make one of the 3 and miss the other 2. Or I can make 2 of the 3 and miss 1. Or I can just make all of the 3 shots. So let's list all of the possibilities. I can make the first one and miss the second and third. Or I can miss the first one, make the second one, and again miss the third one. Or I can miss the first 2, but make the third one. And if I make the first one and the second one, but miss the third one, that also satisfies making at least one of the 3. Again, I can make the first one, miss the second one, then make the third one again. Or I can miss the first one and make the second and third. Finally, if I make all of the 3 free throws, that also satisfies making at least one shot. Let's try to find the probability of the first combination. Since my free throw percentage is 80%, that's same thing as 4 out of 5 in probability. So the probability of making the first one is 4 over 5. If I subtract 4 over 5 from 1, that gives probability of missing the shot, because you either make it or miss it, and there are no other possibilities. So the probability of missing the second shot is 1 over 5, and same thing for the third shot. Now I have to multiply these probabilities, because what happens in the first combination is making the first one and missing the second one and missing the third one. And I told you to multiply the probabilities in AND situations in which all the conditions have to be satisfied. In other words, 2 or more events have to happen together as a combination, and the result will be 4 out of 125. Now, I have to do the same work for all of these combinations, 7 of them altogether. And I would have to add all of the 7 probabilities that I find, because it's OR situation, because they don't happen all together, but either this combination or this combination or this combination, so and so happens. Finding the answer of our question this way may look honest and diligent, but there is a much better and smarter way, and that's looking at the other side of the coin. In other words, look at the opposite side of the coin, since every coin has 2 sides. Let me tell you what I mean by that. When we say make at least one of the 3 shots, the opposite side of the coin is miss all of the 3 shots, because that's all that can happen. When we say make at least one of the 3 shots, that includes making just one of them, or 2 of them, or all 3 of them. And the only possibility that is left to happen is missing all of the 3 shots, making none of them. And let's find the probability of this event. Since we have to miss the first one and miss the second one and miss the third one, we have to multiply the probability 1/5, which is the probability of missing the shot, and by 1/5 and another 1/5, which gives you 1/125 as the result. Now we have to just exclude this possibility from all of the possibilities that can happen, which is 1. So subtract 1 out of 125 from that. If I use the common denominator, 1 can be written as 125 over 125 and minus 1 over 125. And the final answer will be 124 out of 125, which is very much likely to happen. And that is the probability of making at least one of the 3 free throws. So remember, sometimes when things look ugly and complicated, try looking at the opposite side of the coin. Thank you for watching all the time, and I'll see you next time.